We have all experienced the exhaustion of staring at dense textbook paragraphs for hours, watching the pages stack up, only to realize we haven't retained a single piece of information. If you find yourself reading the same sentence over and over, it is likely because the layout of the notes is creating a barrier between the information and your memory. Standard reading moves rigidly from top to bottom, forcing your mind into a strict linear sequence. Human memory, however, does not store information in neat vertical rows. To bridge this gap, we use a system called mind mapping. A mind map is an organizational tool designed for non-linear thinking, allowing information to spread outward from a center point, rather than dropping downward in a list. This diagram illustrates two distinct structures. On the left, you see the standard rigid vertical lines of a textbook. On the right, a central hub sends out dynamic branching connections. This web on the right closely mirrors the actual biological structure of how neurons connect and communicate inside your brain. When your study materials align with your brain's natural wiring, you spend less time wrestling with the formatting of the page and more time building the connections that lead to long-term retention. Imagine trying to drive across a massive, congested city during rush hour, but instead of using a GPS, you only have a dense written list of thousands of street names. That is exactly what reading traditional notes feels like to your brain. Look at this illustration, blending an overhead city grid into a clean, color-coded transit map. This is the alternative strategy, treating your study notes like a navigational tool to establish an immediate visual hierarchy. The core architecture of this map relies on a single destination hub in the center. From that hub, you draw thick, color-coded highways that lead outward directly to specific data regions. Laying out facts geographically like this allows your eyes to instantly skip past unnecessary filler words and jump straight to the exact piece of information you need. Let's look at how to build one of these visual networks from scratch, using the topic of global warming as our test case. This diagram illustrates the first step. Start with a completely blank page and drop your main topic right into the center to act as your primary anchor point. Next, you draw your major highways for the primary subtopics, using distinct colors. This cleanly separates the categories, causes, effects, and solutions. From those main highways, break the data down into smaller streets. The red causes branch forks into pollution and deforestation, adding simple drawings like a factory or a tree stump for an immediate visual hook. You continue this breakdown. The blue effects branch splits into ice melting and heat waves, while the green solutions branch details solar energy and planting trees. By taking this approach, an entire 10-page textbook chapter of dense paragraphs is successfully compressed into a single, instantly readable visual network. When it is time to study for an upcoming exam, your process shifts from rereading paragraphs to recalling a single geometric picture. Because you've built the map, you can navigate directly to the specific fact you need. To ensure these visual maps stay functional, you must apply one advanced tip, the one-word rule. Writing full multi-clause sentences along these branches clutters the navigational pathways, making the map just as difficult to process as the original textbook. Restricting your branches to just one or two key words forces your brain to group individual pieces of data into larger, meaningful clusters. This creates a cleaner layout that is significantly easier to store in your memory. Transforming a text-heavy chapter into a functional visual network changes how you interact with information. By applying this architecture to your next difficult chapter, you can break down complex data into a structure your memory is actually designed to hold.